Okay, thank you for confirming. So I think we can get started. I'll just wait like maybe another like 30 seconds for a few more people to join. I put the link to the notebook in the chat here if you want to just follow along. And yeah, you can just like bookmark it or do as you like. All the code that I'll be running through will be there. So. Okay, I think I can get started. So just expand my screen. Okay, so hello everyone, and welcome to the workshop. So today I will be covering Intro to Data Visualization with Python. So my name is Zach, and I'm from STEM Fellowship, the organization. And just quickly, what we are is we are a student-run nonprofit organization hosting competitions in various different fields in STEM, such as data science, scholarly writing, and physics tournaments. So I'm from the data science committee myself, and for those of you interested, actually, we do have a high school competition coming up in September. We run high school and undergraduate competitions, and our high school one will be this August, actually, is when it opens up, but the competition will start in September. But I can give you more details on that in just a sec, and I think maybe we can send something out after. Yeah, but feel free to check out STEM Fellowship. You can just type it into Google. And yeah, with that, we can begin. So in this workshop, just some things to note. Experience in Python is preferred. It's not like critical. I mean, I see like looking at the poll here, like there is yeah, like a couple of beginners and some intermediates. Oh yeah, sorry, just some questions for the chat. Yeah, so the naming was mixed up. So if you click on that link, it will take you here. But if you click on mine, it'll take you to a different one. It's actually a bit strange. I think if you click maybe, sorry, just a sec. If you click on this here, if you can see my screen, this one, applying the pi principle, you should be able to go to this one. I know it's kind of weird, like it's a bit shifted, but yeah, sorry for that. But yeah, so yeah, thank you for confirming that in the chat. But yeah, so onto the workshops and the visualizations. So yeah, experience in Python is preferred. If you have data frame experience, that'd be great, especially maybe something with like Numpy and pandas. So we'll be going over some visualizations that you can create for yourself in Python. So just to note, the data that I'm using for this is being pulled from an Excel sheet that I downloaded online, which I'll show you how to manipulate and extract data from using Python. So I went to this link here. I'll just click it for you just for demonstration purposes. This link here, I click data and then totals by country. So what this is, it's a UN data set that looks at the migration flow from people amongst different countries for the year 2015. So I clicked A&E, and I'm using the country Canada for this example. I'm just open this up again. Okay, so yeah, I went to this link here, and I just put some instructions here as to how I got this Excel sheet. You'll see a data tab. When you click this page, click on that, and then go to total by country, A to E. It's a zip file. It has a bunch of countries that begin with letters A to E. And then when you see the zip file open, you select Canada, or you can select anyone for your preference, but I just use Canada for this example. And it looks something like this. So this is the Excel sheet. So we have like a nice header here with some titles from rows 1 to 20. And then we have all the metadata beneath that, right? So yeah, and also I should note there are two sheets. One is regions by citizenship. The other one is Canada by citizenship. The one I'll be using is Canada by citizenship, so the second one. And to start making visuals, we need to import the data into a pandas data frame. And and I will specify what that is in a sec. I don't think I actually maybe wrote it here, but that's okay. So pretty much, oh no, I did it here. I'll just get to that in just a moment, what exactly a data frame is for those of you that don't know. So to do that, to import the data into a pandas data frame, we will need to import the pandas and Numpy libraries. So we just import Numpy as NP and pandas as PD. These will allow us to manipulate the data and to do many things with it, to allow us to make the visuals that we want to. And because we're pulling data from an Excel spreadsheet, we also need to import the XLRD library. Yeah, so that's done through this here, this command. Yep, so all good there. And then you should see this message just letting you know if the requirement was successful or unsuccessful. So to avoid any confusion with different operating systems and file paths, I've uploaded the Excel sheet that I downloaded to my Google Drive. Because if you have like a Mac system or a Windows system, the directory or the file path to get to the file will be a bit different. So just to avoid that sort of confusion, I just uploaded it to Google Drive because everyone can do that, provided that you have a Google account, obviously. And then it's just a bit more easier, just pull the data from there. So there's no confusion there. And I will show you how I retrieve it from there into here, into this Python notebook, so we can work on it. So the sheet name that I'll be using for this is called Canada by Citizenship, like I mentioned, the second one. So here are some steps that I have here. So to pull from the drive, we just use the from google.collab command and then import drive, and then drive.mount command, and then this code here. And then what I do is I create a data frame, which is a temporary table, which I wrote down here, but I'll just get to that in a sec. The name of our table or data frame is df_can. And I want to read the Excel file because that's what it is at the moment. So I just use the PD, remember, because we imported pandas, so that's where this comes in handy. PD.readExcel. And then I just specify that it's in my drive. I specify the Excel worksheet name, the sheet name, Canada by Citizenship, which is this second sheet. And then I want to skip rows from 1 to 20. So essentially that's just skipping all of this here because we don't really need this. We just need the data. And then I want to skip the footer as well. And the footer, if you look into the file, you don't have to do that right now, but it's just the last two summation columns summing up all the data, the totals. We don't really need those for this. So once that's done, you should get this message here. And then just to confirm that we have connected correctly, we will display the data set or data frame. And so, yeah, like I mentioned, it's essentially, a data frame is essentially a table that can be changed or manipulated. So it's like a temporary table, excuse me, that you can make changes to, you can cut rows from it, add things to it, etc. And we will call it df_can, which is this here. And so I apply the head function, which just allows us to show the first 5 rows because there are a lot of rows. We don't need to see all of them. So just to sort of recap, so this here is essentially the exact same as what you see here. So I'm just naming this from the Excel df_can, which is now a data frame, or df_can. And I'm just showing you the first 5 rows with the head function. So let's now clean the data set to remove a few unnecessary columns. We'll use the pandas.drop method for this, which you can see here. So the axis equals 1 parameter, represents the rows that we want to get rid of. And then in place is, like row as in you want to get rid of the data for that row. And then we pass an in place parameter is equal to true. And this means that the data is renamed in place. So, excuse me, it's not like copied or returned something different or anything like that. It just gives us what we have, but just modifying the other changes that we made here. And then I show you what that looks like after the changes with the head function. I'm only showing you the first 2 rows though. So the columns that we removed are no longer here, because this is our updated data frame. But now we want to rename the columns so that they make sense to us. So we use the rename method by passing in a dictionary of old and new names as follows, right? So we want to rename the odd name to country. So I do this here, I should mention, using the rename method. So we change odd name to country, we change area name to continent, and we change region name to region. And again, I pass in place equals true. So now we just want to see how that looks. So I just use the columns method, df_can.columns, and this is all the columns in our table or data frame. You can see here we have country now instead of odd name. We have region. Sorry, we have continent instead of area name because we changed it, and region instead of region name. And we have all the years as well, which are all these years here. So what I'm also going to do is I'll also add a total column, which just sums up the total immigrants by country over the entire period. And that is seen here at the very end. You can see we have a total column that just sums all this up. So I'll just specify that here using the sum function. And axis is equal to 1 because it's just summing all the rows across. Axis 1 is equal to, is equivalent to a row. Axis 0 is a column. And then I display what it looks like using the head function. If I didn't use the head function, if I just put df_can, it would show all the rows, just so you know. Like if you're working on it or whatever, and you want to just, you're like wondering why not all the rows are showing, that's why. Now let's remove the index beginning from 0, this column here. In the left column, and our new index will be the country column, right? So I can use the set index function or method, and I just set that to country. So now the country you can see here, and again I pass in place is equal to true, and you can see country here is now the new index and not these numbers. Okay, so now that's all the background stuff done. Now we can get into the actual visualization. So we'll start off with a line plot, and a line plot is a type of plot which displays a series of continuous data points called markers connected by straight lines. So we import Matplotlib as MPL and the scripting interface is PLT. And then I should notice, so this will allow us to plot the graphs. Once you import this into a notebook, you don't have to keep importing it for every visual, but you'll see in a sec, I've sort of done that just to reiterate why it's there, because it's quite prominent here in the plotting. But yeah, so once it's imported at the top or something, you don't really have to worry about it anymore. So if you see it multiple times, it's not really a big problem. So the column names that are integers, such as years, might introduce some confusion if you recall these here. So for example, when referencing the year 2013, one might confuse that with the 2013 positional index, which is not the case. So to avoid this ambiguity, let's convert the column names into strings. So from 1980 to 2013, not the total column, we exclude that. And that's where I do this here below. So below, I convert them into strings, the column names into strings. And then I also pass in a years variable. You'll see why I do this. It's useful for plotting later on. And I range it from 1980 to 2014. This leaves out the total column because it does the second last one. So this actually interprets it as 1980 including to 2013 including. So let's say we're interested in the total number of American immigrants to Canada from the years 1980 to 2013. So to do this, we'll make a data frame, which remember is just like a temporary table called United States, and we'll use the .lock method to search for that country name in our dfcan table, which has everything in it. So I do that here. So I create a new table using this .lock function and just looking for this country here. And then I also pass in the years variable that we just made up here, 1980 to 2013, to exclude the total column at the end. And I do that because this is the result of that. So we get a table that looks like this. You can see here, I display with the head function. We have each year, and we have the number of American immigrants coming to Canada from each of those years. So now to plot, just to make things easier, we're going to change the index values of the United States to type integer for plotting. So the index values are currently years, because if you remember, we converted them into strings. Sorry, we converted all of the columns into strings, but I'm just going to make the index here, which is years in this case, for this United States table. I'm going to make that into an integer just to make it easier to plot with. And then I specify with the plot function the kind I want line for a line plot. And then I just give it a title here, and then I label the axes, and then voila, that's all we have there. So pretty straightforward. You can see here the data for each year from 1980 to 2013. I give it a title, label the axes, and there we go. Line plot has been created. So far so good there, nothing too crazy. Next we have area plots. So an area plot, or also known as an area chart or area graph, is commonly used to represent accumulated totals using numbers or percentages over time. So to do this, again, we import Matplotlib as MLP and its scripting interface pyplot as PLT. But again, you don't have to do this for everyone. I just did it to sort of show the importance if you want to work on just a visual and you're wondering why it's not plotting, because you need to have this as well. But yeah, so in this example, let's say we're interested in finding the top 5 countries with the most immigrants to Canada. So to do this, we find the countries by sorting our data frame in descending order of cumulative total from 1980 to 2013. So if you remember, we made the total column, which sums up all the immigrants from all the years. And we want to put it in descending order because we want to find the top 5, so from highest to lowest. To do that, we use the sort values method. We want to sort on the total column. And then we want to put ascending equals false as this parameter. Axis is equal to 0, implying that we're looking at the column. And then in place is equals true. So we get the top 5 entries because that's what we're focused on here. So we get the, we just make a new table, temporary table called df underscore top 5. And then we use, we apply it to our df underscore can table with the head function. So this just gives us the top 5. It's the same thing. If you want to do more than top 5, you can put like any number here. I can put like 7 in there, or I can put like 2, and it will show you that amount of rows as well. Head by default shows you 5. So we want to transpose the data frame. And essentially what that is like you inverse or switch the columns and the rows, just the labels. And this makes it easier to sort of envision the area plot. We do this by using the transpose method here. And we want to display the transpose data frame. So after all these changes, this is what we're left with here. We're left with these countries with the top 5 immigrants, or top 5 amount of immigrants coming to Canada based on the totals column, but it's only showing the years like 1980 to 1984 because we just applied the head function. If I got rid of the head there, like this, you'd see that it would show all of them. But again, I don't want like too many rows in this, but you get the point. Because it's based off the total column. So something to note, area plots are stacked by default. So to produce, sorry, there's a typo there. To produce an unstacked plot, we pass stacked is equal to false. To produce a stacked area plot, which is what we want to do, it's important to note that each column must be either all positive or all negative values. So any undefined values will be defaulted to 0. And to do that, we're going to first change the index of the top 5 data frame that we have up here. I'll just scroll up. This here. So this is the index, this country column. So we want to make the index integer values, right? So it's easier for plotting instead of string values. So now these are just integer values, and we want to use the plot function again, very similar to what we did before with line plots, but this time we specify the kind is equal to area. Stacked is false. Because we want it unstacked for now. And then we give it a figure size as well, just 20 by 10. And then similarly, we just give it a title here. We label the y-axis, we label the x-axis, and then we show it. Just take one moment. Okay, so yeah, pretty straightforward there. By the way, I'll be answering any questions at the end, so just keep those in mind, or you can type them in the chat. So here is our area plot. You can see the top 5 countries are depicted by a color, each of them. The title, axes, and the years. But you will look at this and you might think it's a bit hard to interpret. So something else to note is just like for aesthetics, the unstacked plot has a default transparency or an alpha value of 0.5. So if you don't pass it in like we did here, we didn't write anything, it just takes it as 0.5 by default. So we can modify this value by passing in the alpha parameter, which I've done here. So again, this is the same thing as what I have here. It's just now I've passed in the alpha parameter to specify transparency. So we'll make it 0.25 for this example, just for demonstration. The alpha value is a value between 0 and 1. It can be an integer, or sorry, not integer, a decimal value or a float value. But this will make it a bit lighter. So you can see here it's the exact same thing as what I have up here, except I just passed an alpha parameter to make it a bit more transparent than you can see here. But notice it might still be a bit hard to interpret. So I'll show you a preferred method for area plots, which is this here. So Notice here that we do not pass the stacked parameter. This is more so the preferred method. So I'm using the top 5 data frame. Again, just to remind you, that's this thing here. So I'm using that, and I'm specifying that I want an area plot, or yeah, sorry, an area plot. And I don't pass in stacked. I just leave that for now because we assume all the values are increasing positively. Or sorry, like the condition that I said here, just to clear that. So each column must be either all positive or all negative values, right? So we're just assuming that in this case. And then I specify alpha to be 0.35, and then the figure size to be this. And then you can see here, it looks a lot nicer and it's a lot easier to sort of interpret. Like nothing is overlapping each other, like in this sense. It's very easy to pull data from and to make analysis and inference from. So again, I just make a title, label the axes, and then there you go. This is the modified area plot. So all is good there. Let's check on time, okay. So next we have a histogram. So a histogram is a way of representing the frequency distribution of a variable. So again, yeah, we have this step again, but I'm just going to skip this because every visual has its own step, to use these scripting interface, but you get the point, right? It's already imported once in the workbook. So I'll just skip that from now on. So let's look at visualizing the distribution of immigrants to Canada in the year 2013. So to specify this, we just, very similarly, we index or focus on the 2013 column. We use the plot function, specify the kind is histogram, give it a figure size as well. You don't have to give it a figure size, like sometimes we'll just default one, but if you want a specific figure size to be bigger or smaller, you can specify. If you don't specify, it doesn't matter, it'll still show it. And then similarly, we just give it a title, label the axes, and here you go. So here's our histogram, but you notice here that the bins do not really align with the data bars. You can see here, they're kind of overlapping each other here. So we'll take a closer look into how we can fix that. So the histogram method, which I have down here, I'll just scroll down a bit, which I have down here, by default, it categorizes the data values into 10 bins, which you can see in the image below, which is what it's doing here. So there are 10 different bins, if I go along the graph here, and you can also see here in the picture, and it will just sort of categorize them so we don't have any overlapping issues here. So this can be ensured by passing in an xticks keyword that contains the list of the bin sizes as follows, right? So this is what that is. It's a list of all the bins here, and it's pulled in here. So before I go there, I'll just explain quickly. So we have the histogram method that breaks up the data set into 10 bins by default, which it does here. I'm just giving it a name here, bin edges, and I'm just counting them. That's all that's going on here. And this is for the year 2013. And then we just do what we did before. We plot it, the kind is histogram, but then we pass in the parameter xticks, bin edges. So, and then we've counted it here, so we know how many there are. And we know what the count is for each one, like the frequency, like 178, 11, 1, so on. So that's specified here with xticks, so we don't have any overlapping data bars. And again, I just give it a title, label the axes, and there you go. And you can see now it's a bit squished, but they're not overlapping. Like each column has its own threshold, so we don't have this problem that we had up here. So all is well there. Okay, bar charts. So, oh, sorry. Okay, bar chart. So a bar chart is commonly used to compare the values of a variable at a given point in time. So let's say for this example, we want to look at annual immigration from Iceland to Canada from the years 1980 to 2013. So the same one that we made as earlier. We made a years variable, which is just a list of all the years. Like just writing 1980, 1981, 82, so on to 2013. So yeah, same one that we made before. We exclude the total column for now because we don't want that for this visual. So that's why this is not including 2014. It's including this one, but excluding this one. So this will be 2013. We want to create a new data frame looking up Iceland because we're looking at Iceland for this example. So I specify that df_Iceland. I take a look at our old data frame or the original one with all the metadata, df_can. I use the .lock method, just look up Iceland because that's what we're focused on only, and I want years passed in just so we know the years that are being associated with each sorry, the amount of immigrants coming in for each year. And just to show you, actually, I can show you what that looks like before it's plotted. Run this first. Okay, I'd have to run this all again, but that's why it's going to be there. Sorry. Okay. Okay. Sorry, just a bit of a delay. Just be 1 sec because I'm pulling it from my Google Drive, so I just need to do this real quick. Okay. Okay, so yeah, so this is what it looks like here, our Iceland data frame. We have the years, 1980 to 2013, and then we have the number of immigrants for each year. So this is just this, the result of that. So all is well so far. So then, similarly, we just specify the type that we want to plot. Very handy that some of these visuals have this parameter where you can just pass in the kind of what it is, and then it just does it for us. So we specify the type, plot the title and labels for each axis like we did before. So we're just focused, we take a look at this data frame now, or this table, DF Iceland. We want to plot it so it's a bar graph, and then we just give it a color, just for aesthetics. We just give it green, for example. You can see there the title, the axes labels, and voila, here is the bar chart for Iceland. See the years on the bottom, number of immigrants as well, all is well there. So pie charts, and a pie chart obviously is a circular statistical graph that divides the pie into slices to illustrate numerical proportion. So let's say for this example, we want to take a look at immigration to Canada based on which continent they're coming from. So to know which continent we're coming from, the data set that we have, df_can, or from that big Excel file, specifies each country, so it doesn't group the continents like for us, so we'll have to do that here. We will call the pandas.groupBy function, which is, function to df_can, and then we use the number of immigrants from the countries that belong to the same continent. So we have a new table here. Again, we just want to look at our big table and group by continent. So we have that continent column. If you recall, I think, just go up here. Yeah, continent here. So now we want to just group them, right? Because here it's showing it by country, but we just want to show it so each row is a grouped continent. So we do that using the group by function. We specify which column we want, the axis label 0, so it's just grouping all the column values together, like for each country. So because remember, it's written by country, so it's just summing up the countries that are in the same continent together, and then we use the sum function to do that. So let's see what df continents looks like after we apply the group by and sum method. So this is our continents table or data frame. We have all the continents here grouped together, and then the years all through 1980 to 2013 plus the total, and then we have the number of immigrants for each year in each continent. So above is our data frame that I just called df_continent, which now displays each continent as a row and 35 columns representing the years from 1980 to 2013, plus the cumulative sum for each continent at the total. That's just the total column at the end. And now we can create our pie chart. So we have our data frame, df_continents. We just focus here on the total column here, which I specify here. So we want to plot a pie chart based on the total column. And we just specify, again, kind is equal to pi for pie chart. And it just kind of takes care of it for us. You can see here, we just give it a title, and then there you go. We use the show function, and that's our pie chart. Again, nice and easy, straightforward. Next, we have a box plot. So a box plot is a way of representing the distribution of given data through 5 main dimensions. So we have the minimum, which is the smallest number. We have the first quartile, which is the 0.25% of the way through. We have the median, which is the middle point. We have the third quartile, which is 75% of the way. And we have the maximum, which is the highest number. So you can see, we're not going to have outliers in this diagram here, but you can see here from the diagram. Actually, I should go through the code first before I do that. So yeah, now let's say we want to visualize the immigration numbers from Japan to Canada using a box plot. It's very common in statistics that you'll find the usage of box plots. So we create a new data frame called df_Japan, referencing the main data frame, df_can. Use the lock function for Japan. We throw in the years variable as well. And again, this will just kind of give us what we had for Iceland, like what I showed you before. But now we want to transpose. Again, transposing just makes you don't necessarily have to transpose it, but it's just a bit easier to see, which is why I do it. But if you don't transpose it, it's fine. It's not wrong or anything. So then I just plot the kind is equal to box. And remember, sorry, transpose means you just flip the columns and the rows. So I look at our df Japan table, which is similar to the Iceland one, except now the rows and the columns are just flipped. So I specify the kind is equal to box. I plot title and the label, and then yeah, that's pretty much it for the box plot. So looking at the diagram, so a minimum is this line here. You can see this line at the very bottom. That's the minimum. That's the smallest value. So for all the years, the smallest value is 200, it looks like. Then we have the first quartile, which is this here. So it's the 0.25% of the way through the data set. So what that means is when you sort the data, when you go 25% of the way through from the years from 1980 to 2013, so maybe that's 1990 or something, whatever it is, 25% of the way up, you will get this value here. Or sorry, when sorted, when it's sorted ascendingly, from the amount of immigrants coming in for every year, excuse me, and then we have the median value, so it's the middle point when sorted numerically, obviously, and then we have the maximum. Sorry, this is the third quartile, excuse me, the 0.75% of the way, and then we have the maximum here. So this is just when you sort the amount of immigrants coming in, not with the year necessarily, but each one's tied to a year, yes. But you would sort the number of immigrants in an ascending order. So smallest, no matter what the year is, it could be the year 2000, even though 1980s before, it doesn't matter. It just has a year tied to it, but you sort the populations based on ascending order. So smallest to biggest. And then once again, this is the minimum. This is a quarter of the way through from that order, or from that sorting. This is the median point. This is 75% of the way through the third quartile, and this is the maximum. So that is our box plot. Next, we have a scatter plot. So a scatter plot. Excuse me, one moment. A scatter plot displays two variables against each other. We have an independent variable, which is the x variable on the bottom, or from left to right, I should say. And then we have the dependent variable, or y value, which is going from top to bottom here on the vertical. And we try to see if there's a correlation between the two, from which you can draw a conclusion. Maybe if x happens, then y is bound to happen, or if there's no correlation, then if x happens, then it won't necessarily result in a y. There's not a strong outcome between the two. So again, let's say we're interested in the total annual immigration to Canada from 1980 to 2013. To do this, we'll need to create a data frame that shows each year and the corresponding total number of immigrants from all the countries in DF Canada. Sorry, it's supposed to be DF Can, but yeah. Okay, yeah. So we will call this DF total, and this is how we get it. So what we're doing is we are essentially summing up the data for all the years for all the years, because we're just focused on the total amount of immigrants for each year. So we create a new data frame called df total. we put in the data frame argument, pd.dataframe, and then we want to specify it's the years column being summed up, and we throw in axis 0. So this just gives us the total population per year. And axis 0, remember that's for the column, so it's just summing that up. Like for each country, I mean, for like DFCAN. And then we change the years to type integer. So this is useful for regression later on, for plotting purposes, like we did before. It's the same thing. So we just make sure the index, and then we have the index here, we specify. And then the index is just, like it's the, essentially what it is like you can see here when I transform it, this is the new index. But we just map it so it's an integer, not a string. So, and then I reset the index to put it back in as a column in the df total data frame. So yeah, that's what this essentially is here. And then I rename the columns just to year and total, and then I show what that is. I show the result of that here. So this is our df underscore total data frame. Each year is indexed here. We have the years, and we have the total amount of immigrants coming to Canada in each of those years. So step 2, now we plot the data. So in Matplotlib, we can create a scatter plot by passing in kind is equal to scatter as a plot argument, similarly to what we've done before. But for this one, a bit different. We also need to pass in X and Y keywords. The other ones we didn't. It just knew what to do. But in this one, you have to pass in X and Y keywords to specify the columns for the X and Y axis to know which one's X and which one's Y. So looking at our df total data frame, which is this here, I use the plot function. Specify certain parameters. The kind is equal to scatter. X is year, so this goes on the x-axis on the bottom, and then Y is total, which is here on the vertical. Excuse me. I give it a figure size. Again, that's not necessary, but just to sort of like expand it a bit, magnify it, and then I give it a color. I say dark blue, just for some aesthetic purpose. So here's our scatter plot. You can see all the points. I again give it a title, label the axes, and then I show it. Now that we've plotted our data points, let's create a linear line of best fit, which is a line that best shows the correlation and tries to connect all the dots by going through all these data points. It's not like a line plot where you connect it. What it is, in this case, because it's linear, it's just a straight line trying to drive through all of these points as accurately as possible, trying to be closest to each one as it can. I'll show you that in just a sec. So to get the equation of the line of best fit, which is y equals mx plus b or ax plus b, you probably learned that a long time ago in school. We will use Numpy's polyfit method by passing in the following. So we have an x value for the x coordinates of the data, which is the years in this case. This is the x-axis, and then we have a y value, which is the number of immigrants, or the y coordinate. And then we have a degree of the polynomial, 1 for linear, 2 for quadratic, etc. In this case, because it's linear, it's a line of linear line of best fit like that. We'll just specify the degree to be 1. So the x value I specify is the year column, which is this. So this is our x, if you recall. So I specify that here. Y is the total column. So again, x here, y here. And then I pass in the fit array. So what fit is that it uses it's an array that I will store the polyfit output in. So remember I said we'll use the polyfit method to pass in the following to get the coordinate or the equation for line of best fit. I pass in x, which is the year, excuse me. I pass in y, which is total, and degree is 1, which means linear. So it's like a straight line like this. So it's nothing like a quadratic like that or anything. So then just to show you what that gives us, I will then output fit. So like I said, fit is an array with the polynomial coefficients with the highest powers first. So that means the one to the very right is a constant, which is our y-intercept if we're looking at our line of best fit, because remember it's y equals mx plus b, or ax plus b in this case. A is the slope. It has a degree of 1. Remember, I specified that here because it's linear. B is the y-intercept, which is a constant. So our output here has 2 elements. The first one is the slope, and the second one is the y-intercept. So we have y equals ax plus b. So this is our a, which is our slope, and then we have the b value, which is the y-intercept, which is this. It's just 2 numbers, essentially, is what it is. Now that we have our slope equation, or our line of best fit, I should say, equation for that, we will plot the regression line onto the scatter plot. So again, I just do what I did before. This is just plotting all the dots here for the scatter plot. Again, giving it a title and whatnot, just to make it look nice. But here's where I plot the line of best fit. So I use the plot function. I specify x, which is the year. So if I just go down a bit, you can see that for every year, it's like essentially a straight line. You can think of it as like a bunch of like mini dots. That's essentially what it is. So it's plotting all the x's, and then we index the first value from the fit array, which is this here, which is this. So this is the slope value. Because we want to specify like an x and a y value. So the x values are like really close together. You can see, and then we have a fit. We index the first value from the fit, so this is our y value. So remember, y is equal to ax plus b. So we have this, which is our a, times x plus b, which is the second value. I know it's 0 and 1 because that's just how we index. 0 is the first value of an array, and 1 is the second value of an array. So we have the x value, which is all the years, 1980 to 2013. We have the y value, which is the y equation here, which is our slope equation, or our line of best fit, I should say, which is a, which is this, the a value, and times x plus b, which is this value here. You can see from the fit array. And I give it a color. I'll just make it red. So recall that, yeah, x is the years here. And then we annotate. So again, I'm just essentially, like, that's what this is doing here, just showing you the actual equation. You don't have to do this. It's just optional. So so y is equal to 0 to 0f. I just formatted it here, like the fit array of the 0 index, the first value. I just gave it a little format, and then that's what this is here. And then we have the x, which you can see here. And then we have the plus b value, the intercept, which is what I'm doing here. Again, I'm just kind of formatting it, just specifying like what's going where. So this is the first value of here, and this is the value of this. And then I just give it a position where I'm going to plot it on the graph. So it's going to go to the year 2000 and plot it at 15 or 150,000 here, and that's where it displays on the graph with this. And then I just show it, right? You need this to show. And then I print out the line of best fit. Essentially, yeah, sorry, this is just, the equation for line of best fit, I should say. So we have the number of, I'll just write that here, actually print out the equation. Equation of line of best fit. So then number of immigrants, which is down here, by the way. So number of immigrants is this, same thing that I formatted here, times the year, and then plus the y-intercept. In this case, it's a negative, so it'll just be minus. All right, so that's all good there. Next, we have a bubble plot. So a bubble plot is a variation of the scatter plot, which uses bubbles to depict data points. The size of the bubble is determined by the weight of the data points. So I'll get into that just in a sec as to how we compute those, like those marginalized weights. So we'll look at, let's look at immigration to Canada from Brazil and Argentina over the years. So first, we will make a new data frame called df_can_t, where we have converted the year's value to type integer. So again, I take our original data frame with the years, and I just transpose it. That's essentially what's going on here. But yeah, so then I just change the years or the index to type int, which I've done here. Just map that as a type integer, just to make it easier for plotting. And then I will label the index, and this will automatically be the column when we reset the index, and I'll show you that in just a sec. So the index is the year, so it's no longer like this sequence of numbers here. So the index is now year. I just use the index.name method, and then we reset the index to bring the year in as a column, right? So that's what it's doing here. So I just reset the index now, so essentially just kind of like shifting it over, essentially. And it's essentially like now the index, the index is going to be like this string of numbers, but it will represent each year is what I mean. So like it will be 0, 1, 2, 3 without the year, and I'll show you that in just a sec. So then we show the changes that we've done. So here's our table now. And now that we have the transposed data frame, again, transposing it just makes it easier to sort of envision. Not necessary though. We will create the normalized weights using something called feature scaling and statistics. So what this does is that it allows us to proportion all of the data values compared to the max value in our data set. So it's done with this mathematical formula. So x prime is equal to x, which is every sample, or in this case, the population, like any one of these, the population for a country of any certain year minus the smallest one minus x min, or any observation minus the smallest observation divided by the biggest observation minus the small observation. So, and like I said, x is the sample data point, x max is the max value for the data point, x min is the smallest one. And that's done for every country and for every year, right? But in this case, we're only doing Brazil and Argentina, so that's why you can see here, like for example, for Brazil, I just specify Brazil. So what this is doing here, we're normalizing the Brazil data to find a formula for x prime, to find the formula for this. And so I look at our transposed data frame, I go to Brazil. I don't think it's actually showing here, but that's not really a big problem. I guess it is, but I just don't really have time to look for it. That's why we just specify it here. It doesn't really matter. So I specify Brazil. So this is the x for every observation in Brazil, and then I minus the smallest value using the .min function, which is what I'm doing here. This is the numerator essentially. So every point minus the smallest one, and then I compute the denominator. So I have x max here, which is the max for Brazil. I specify Brazil, I use the .max method, and then I subtract it with the minimum, or the smallest value, the smallest population for Brazil over all the years. That's what's going on here, and this is essentially this equation. This is the same thing, but I'm just focusing on Brazil at this point. And then I do the same thing for Argentina, exact same arithmetic, except I just changed Brazil to Argentina, and there you go. And the result of that is this. So for every year, which we've now indexed as 0 to 33, it's giving me a number. And what this number is that it's a normalized weight for each of the population amount or migration amount for the total amount. So what that is like, you can see, for example, we have a 1. 1 is the biggest one, right? This is all in perspective to the biggest, because that's what this formula does for us. We have a 0, which is a small value. If you put like a 0 in this, for one of these, like one observations, you'll have 0 minus the min, which is also a 0, and then divide. So you have 0 in the numerator, so it becomes 0 immediately. The biggest point, we have the biggest minus the smallest. We'll have like a 1 minus 0, so we have 1 in the numerator and then the same thing in the denominator. So these are just proportions for each of the bubbles for the amount of immigrants for each year. 1 being the biggest one, and then 0 being the smallest one. So that's what it looks like for Brazil. And then for Argentina, it's the same thing. Exactly the same thing. So we have 1, they have 0. Like the data, like the numbers aren't the same, but like it's the same concept. It's just proportionalizing the bubbles based off the biggest and the smallest ones, or just the biggest ones, I should say. Sorry, because it has to scale it to something. So now we'll plot the data for each country, and we'll see how that looks. So I create this variable here, or the subplot, using this transposed data frame. that we made, which is essentially this one here, the df_can_t. And then I just specify the kind as a scatter plot because that's what it is essentially. It's just a modified scatter plot with weightings for each data point. So x I specify as year. That's from the table here again. That's from this here. This is year. This is from the x-axis. For my y-axis, I want Brazil. So I specify that. So it's pulling the Brazil column from that table. I give it a figure size. Again, we have an alpha parameter for transparency. Just if you want a transparent or translucent or opaque, as you like, from 0 to 1 again. Maybe I should just note that down. So it's a value from 0 to 1. I give it a color, and then I pass in the weightings that we just created. So that's what this is. This is for Argentina, but norm Brazil is the one up here, and that's what I'm doing here. And you can see I multiply it by 2,000 and add 10. This is just to kind of scale it up, because if I don't do this, it'll be really small. You won't be able to see it. So I just kind of expand them all and magnify them. So it's very easy to see on the graph. And I add 10 to compensate for the minimum value, because if I left it as it was, it would just be 0, right? Because if you remember, there was a 0. So I multiply all of them by 2,000. The 0 would still be 0. So I have to add 10 just to make sure it's visible on the graph. So those, like this here is just making sure like you can actually see it, so it's not too small. Then I limit the x-axis, or the x-axis to the years 1975 to 2015. Again, this is optional. Like this is just for aesthetics. You don't have to do this. And then for Argentina, it's the same thing. I just specify it again. Kind scatter. X-axis is the year, but for the y, we want the Argentina values. So what that is, it's looking at Argentina in this table, and it's taking those values. And then the color is blue, and then I pass in the same normalized weights that we created up here, scale them up so we can see them. And then, yeah. I just call it, so I just make sure that we have the Brazil plot as well, because if I don't do this, we won't see the Brazil plot because it will only plot one thing. So I just pass in this to make sure we see the Brazil and Argentina both plotted on the same graph. How are we doing for time? Okay, we're a bit short because we had a delay at the beginning, but I'll try to see if I can go through this quickly. So then we set a label, a legend up here. And then we have title, and yeah, that's pretty much it. So these are the bubble plots. You can see everything is proportionalized. And yeah, that's pretty much it, really. Self-explanatory there. Next, we have Seaborn. So Seaborn, what it is, Seaborn and regression plots, I should say. Seaborn is a Python visualization library based on Matplotlib. So it provides a high-level interface for drawing statistical graphs. From our previous scatterplot example, when we tried adding a regression line, if you guys remember, when we went up a bit, it took about 20 lines of code. So we'll see how efficient Seaborn is in regarding this issue, right? So it's a more efficient way of plotting a regression line. So first we install Seaborn, just using this command here, if you don't have it on your system already. And then we're going to refer to the total data frame that we made, so listing all the columns, or the summation of all the immigrants for each of the years to Canada. So with Seaborn, generating a regression plot is actually as simple as calling the regplot function. So we'll also change the line and marker colors as well, and we'll add a custom marker, title, and label names. So I do that just down here. I have specified the figure size with the figure method. Again, this is like not optional, but I did this just to make it bigger so you can see what's going on. And I use the Seaborn method here, sns.set. Remember how we imported Seaborn as SNS. So this is referring to Seaborn. So yeah, just sort of scaling the font, or like scaling the size of the like plot, or the line itself onto the graph, so it's a certain size. And we have like the shadow in the back as well. That's just kind of dealing with that. And then we specify the style, so we just change this to white grid, which changes the background to white grid with tick marks. And then we specify the regression plot itself. So we call it AX, which is just going to be like the line, obviously. And then we have sns.regplot, which is what we're doing now. We're specifying a regression plot. So again, it's quite easier than creating like a function like we did before, like an equation. So I just pass in the year parameter, x is equal to year, y is equal to total, so it knows which one goes where. For my data, I'm using the df_total data, so it knows what that is actually being used. Marker, or sorry, which table or data frame is being used, and then marker. I just made a custom one. I just put like plus marks, but you can do anything. You can do like this, like literally like you can do many things. So I just picked that one. And then we have this parameter, scatter_kws. So this allows us to adjust the size and color of the markers. So I made them a size 200, and I just made them blue. This is just to show you that we can do things aesthetically as well. It doesn't have to be like a default color or font or whatever that you have to stick with. And then I have one similarly for line. So again, this allows us to adjust the color and thickness of the regression line itself. So I made the thickness 2. I can make it like really thick by just making it bigger, and then vice versa. And then I just made it a red color, which you can see here. So, and then I set the labels. The x-axis is the year, the y-axis is the total, and then I have a title of immigration to Canada from these years, 1980 to 2013. So again, very similar, straightforward. This is a much more efficient way of doing regression plotting. I have like, I think 2 minutes left. I'll just try and finish up real quick. So this should be kind of quick. So again, this is the last sort of topic: maps and geospatial data. So this is how we plot maps in Python. So Folium is a Python library that helps us do this. With Folium, you can create a map of any location in the world as long as you know its latitude and longitude values, which is a specific coordinate on the map. It's a pinpoint to a certain place. You can also impose markers and clusters on the map for informative visualizations. So similarly, first what we're going to do is we're going to install the Folium package, like we did before with Seaborn, but it's done a bit differently here. You just use this code to install Folium. You'll get this confirmation message. And then we import the Folium module so we can make a map. And that's just done here with import Folium. Then we define the world map. So we set world map is equal to folium.map. So this is the map method, and it knows that it's a world map, so it just puts it here. And this is what it looks like. So we display the world map. So now we have a world map here done with Folium. So far so good. This is just the world map. And then here, let's say I want to focus on Canada. So again, you have to know the latitude and longitudinal coordinates to focus on a place. You can also set a zoom parameter to see like how closely you want to be zoomed in. You can also change this after, it doesn't really matter. Or you can also like not even have it there if you want. This just specifies the zoom level. So world map, and then I have our folium.map method, but then I specify the location as these coordinates here, which is like focusing on Canada. Then I have a zoom level as well. So how much we're magnified into the actual location, or how far we're away from it, or focused away from it. And then I display it. So this gives me this. So that's a pretty good way to like just show a map. Another great feature of Folium is that you can create different map styles using the tiles parameter. And so let's try like a stem and toner map, for example, which is what this looks like. So we'll introduce the tiles parameter and make it equal to stem and toner. So again, similarly, we just have our world map variable. We use the folium.map method, specify the location. The zoom is the same thing, but then we just add in the tiles parameter to make it stem and toner. And here we go. Here's what it looks like once we display it. Just a different theme, just a different look, really. And similarly, we can do the exact same thing. I'm kind of running out of time, so I'm going to go through this a bit quickly. Similarly, we do the same thing, but we just make tiles equal to stem and terrain, just for like another sort of theme map. And here you go. This is a terrain map of Canada. Again, it's the same thing. And last but not least, we have maps with markers. So referring to our original map of Canada, we'll make a marker for Ontario, which is this province here. So we generate the map, same thing as before that we did with the world map, exact same thing here, but we just call it Canada map. And then we have Canada map, we display it, so that gives us this. And essentially, first we'll create a feature group named Ontario, which essentially is just adding the marker to a certain point in Ontario. So we created a feature group for that. So the line below is the feature group, and we'll see how this is integrated within the code in just a moment. So I just use the feature .feature group method for that, and I call the feature group Ontario. And since the feature group is empty when first created, we will style the feature group with a child in the form of a red circular mark located at the center of Ontario by passing its latitude and longitude values. Once we've done that, we can label it using the marker function, and then we add it to the map. So again, here's our map of Canada that we had up here. So we had our we had our feature group for Ontario that we just did up here. Now we style it. So like I said, we'll make it red. So we specify the coordinates of where we want it. Specifically, it's going to be right there, if you can see. Oh, sorry. So yeah, that's where we want it. So we just we add the child, use the add child method. So we have our feature group, and then we add the child, which is like essentially adding it to adding the characteristics of the feature group. So that's the things like we make it a circle, which I specify here. Oh, sorry, 1 second. So we make it a circle using this method, specify where we want it exactly on the map, the size, the color, and the fill color. And then we add the feature group that we just made to the map. So the group here, which is that marker now. So we add that marker, Ontario, which is all of this, to the map of Canada, right? And you can see I'm going to add a little marker as well. If I click on it, you'll see that Ontario should pop up. There it is, and that's what I do here. That's what I label the marker. With folium.marker, I specify where it goes, obviously, with the coordinates. The message, I just put Ontario, and we use the add to method to add to Canada map, and then we display the map. And that's it, really. Then we have our map displayed with our marker. And that's all from me. I know I was a bit over time. Sorry about that. Sorry, I see 800. I'm not too sure what that is. Oh, the Python link. Okay, sorry about that. So you have, I think I maybe have to find out how to give access. Okay, maybe I just hit share. But yeah, were there any questions about yeah, post the links? Yeah, for sure. I'll post the link. For some reason it's restricted. Okay, 1 sec. Is it possible to get the regression value using Python? Like by regression value, you mean like what do you mean exactly? Like the equation that we just made, or? To answer your question, yeah, it is. Seaborn just allows us to do that in a much more efficient way. I'm not too sure. Sorry, what are like the comments here? Like, how many people are tuned in? I guess maybe. If that's the case, then wow, that's a great turnout. But yeah, in math, it symbolizes R2. I'm not sure what it is meant. R2, like an R2 space, like a two-dimensional space. Is that what you're talking about? I'm not too sure. I'm like, I mean, to answer your question, yes. Okay, there's a bit of a. If only people in my organization can see. Oh, okay. Anyone with the link? Okay, great. Sorry about that. So anyone with the link can view, and I'll send you the link again. Yeah, R2, R squared. Yeah. Oh, sorry. Was that written here and I didn't explain it? Oh, sorry if that was the case. Oh, excuse me. Yeah, so you should have access now. I'll just send you the link once again. So here's a link to the. There you are. I think it is called an R2 value. Yeah, like I guess it's like it can be notated in different ways, but yeah, I see what you mean. R squared. Okay, yeah, okay, no, that's fine. Yeah, no worries. No problem, no problem. Yeah, I hope that answered the question. If it's possible to get the regression values in Python. I guess like there probably is a library for that, but I think Seaborn like just trying to see if like Seaborn can actually like display it. Maybe there is. I'm not too sure to be honest, but yeah, I know like with the regplot or the like polyfit it does. So yeah, you're able to get it through Python essentially. Yeah. But yeah, if that's all for me, I guess if I'll just wait for like maybe another minute if there are more questions. I know we're over time. Sorry about that, but thank you for coming, everyone. So yeah, once again, the link to the notebook is in the chat, and I'll just stick around for a bit more if there are any questions. Yep, no problem. I'm glad I was able to answer it. Do you have any good resources for practice? Yeah, there's a site here. Cognitive class. This is not a bad site. Like where we sort of like you can just use this whole site essentially. I'll just link the website, but it's a good site. A lot of things with Python there you can check out. And yeah, no, definitely a good place to go and practice. Yeah, for sure. Okay, but if that's all, I guess I'll just leave. But yeah, once again, thanks. Thank you all for watching, and yeah, hope you enjoy the rest of the sessions. Take care, everyone.